For this particular one, I chose as the example sodium bicarbonate. Now, HCO3 is called bicarbonate, and the bi in that has nothing to do with the number 2. Okay, it comes from an old nomenclature. The prefix was bis, B-I-S, and it got shortened to bi. You just need to know HCO3, bicarbonate. That's one of the polyatomic ions I expect you to memorize. But carbonates, including bicarbonates and sulfates and sulfites, when they are in a compound that acts as a base, and that's what this would be. Now, this is sodium bicarbonate. This is baking soda. And it is going to act as a base. When that reacts with an acid, like here I chose hydrochloric acid, here's what's going to happen. Remember that when an acid reacts with a base, there are 2 things that you always get. The first one is water. Okay. The second one is some type of salt. Now, the salt always happens when the cation of the base, okay, so that's the positive part, so that's the sodium, gets together with the anion or negative part of the acid. Another way to say it is that the cation, which is almost always a metal from your base, gets together with the conjugate base of the acid. It's just another way to say it. Some of you won't get that. We haven't talked about conjugates yet. But we can say this. The negative part, the anion from the acid, is the chloride. So our salt is going to be sodium chloride. Okay. Now, where did the water come from? Well, you always need to take the hydrogen from your acid, so that's here. And then to make water, we need another hydrogen, and that one is here. And we need an oxygen, and there are 3. So we're going to use one of those 3 oxygens. So that hydrogen, and one of those 3 oxygens makes the water. But that doesn't account for everything. That's got the hydrogens and one of the oxygens. That's got the sodium. It's got the chlorine. What is left? Well, what's left is the carbon here and the other 2 oxygens. So in other words, when carbonates, bicarbonates, sulfates, sulfites act as bases and react with an acid like hydrochloric, we don't just get water and salt, we get some type of gas. In this case, we get carbon dioxide gas. Now remember, we can indicate that it's gas with the letter G. Some texts will instead use an up arrow to say that that carbon dioxide gas will bubble up, come up out of the mixture. Okay? Now, let me do another example of this, and this is one that you may be, there's a very good chance you're familiar with this one. It looks a little more complicated on paper. So, for my acid, I'm going to take HC2H3O2. Can you name that yet? We've been far enough, you should be able to. It has a hydrogen in the front. That tells you it's an acid. It's not a binary acid. There's more than one other element here, so it's not hydro something acid. We need to know the name of this polyatomic ion. And this is one of the ones I expect you to remember. It's called acetate. So we take that, acetate, and the ate becomes ic. So this is the formula for acetic acid. I'll write that down. Acetic acid. And this is what is in vinegar. Okay, now let's react that one with sodium bicarbonate. By the way, sodium bicarbonate can be called sodium hydrogen carbonate, but nobody does. And I want you to know bicarbonate. It's very common. All right, now this is baking soda. So have you ever put vinegar and baking soda together? Most people have. So what do we get? Well, this is an acid, and baking soda is a weak base. Technically, it is a salt made from a weak acid and a strong base, but we won't go there now. We're not to that point. So what do we get? We know we have to get water. And we have to get some type of salt. All right, so let's find our water first, shall we? We know that the water comes from the hydrogen from the acid. And then over here we have another hydrogen and one of these three oxygens, just like happened up here. So that's where the water comes from. What will the salt be? Well, remember, take the metal, or take the cation, the positive part of the base. Well, that is the sodium. If nothing else, we know that it's positive because you always put the positive thing on the left and the negative thing on the right. So what is positive over here? The hydrogen is. So what does that mean about the acetate? Well, you're supposed to have it memorized anyway. Acetate has a negative charge. So our salt is sodium acetate. Sodium has a +1 charge, acetate has a -1 charge, so that is neutral. And then we use the hydrogen, the oxygen, the sodium, the acetate. What's left? Carbon dioxide. So when you put baking soda and vinegar together and it makes bubbles, the bubbles are carbon dioxide gas. All right, so there's a couple of examples of an acid-base neutralization reaction with gas formation.